Hi, this is Algebra 1, Module 4, Lesson 7, Practice Problems. We're going to start off with um, a graph. We have an equation up here, and then we're going to fill in the table accordingly. So I'm going to show you with one of the equations and one of the explicit equations and one with the recursive. Um, so here we have -3. So if I put in a -3 for x, so on this first one, it's going to be a -2 times -3 plus 7. So -2 times -3 is 6. 6 plus 7 is 13. Next one, I'm going to plug in a 0. So that makes us have -2 times 0 plus 7. Well, that's going to leave us with just 7. Anything times 0 is 0. Here, my answer needs to be 43. So I'm going to take 43 equals -2x plus 7. So now I have to go through that process of simplifying here. 43 minus 7 is 36 equals -2x. Divide both sides by -2. So 36 divided by -2 is -18. And then now I've got the 21. So -2 times 21 plus 7. That's 42 plus 7. Oh, negative 42 plus 7 gives me a -35. All right, so then I'm going to, so same idea when you're over on this one. So now I'll show you how it works with a recursive function. So over here, um, we have h of x equals the previous term plus 6. So h of 1 is -13. So if I have one, let's see, 1 is -13, and I'm going to add 6 each time, then I'm going to probably want to come up with an explicit equation because if I'm going to have to start plugging in numbers, I don't want to have to count all the way up to 15. So let's go ahead and figure out what our explicit equation is from here. We'll change colors. So my h of x equals, well, I'm starting with a -13, and I'm going to add 6 repeatedly, and I have the first term. So that is my explicit equation. So for 3 and 4, you'll want to make the explicit equation so that you can then plug in. So now I can plug in a 3. Well, 3 minus 1 is 2. 6 times 2 is 12. 12 plus -13 is a -1. Let's try with the 15. 15 minus 1 is 14. 6 times 14, don't know that one off the top of my head, is 84. 84 plus a -13 is 71. Aren't you glad we did the explicit for that? I'm actually going to simplify this a little bit before I plug in for my x. So I'm going to distribute my 6 to both of those. So h of x equals -13 plus 6x minus 6. So then my explicit is a little bit cleaner for when I have to plug in my y's. So -13 minus 6 is -19 plus 6x. So now when I plug in a 5 equals -19 plus 6x, I don't have to deal with those parentheses. So I'm going to plus 19 to both sides. That is 24 equals 6x. Well, 6 times 4 is 24. And then my next one, 23 equals negative 19 plus 6x. So I'm going to add 19. Those cancel. 23 plus 19 is 42 equals 6x. And is that right? 2, carry the 1, yep. So 42 divided by 6, oh yeah, 7. 7 times 6 is 42. All right. One more we're going to look at. Let's look at number 6, where we have this x plus y. So, there. So basically, I'm going to plug in the 10 for x. 10 plus y equals 24. If I subtract 10 from both sides, then y equals 14. Well, now I have a 0 in there. So instead of 0 for x, I'm going to put it in for the y. So x plus 0 equals 24. Well, that one I know in my head. 24 plus 0 equals 24. How about a negative 20? X plus negative 20 equals 24. To get rid of a negative 20, I have to add 20, positive 20. So x equals 44. And then if x is 0, 0 plus what equals 24? We're back to what we just had earlier with 24. So that's how you can do that when they're both on the same side. Still substitute in. So I'm going to leave 2, 4, and 5 for you guys. I can do, we'll just find the explicit for 4 and then you can go from there. So here I'm going to start with 34, right? That's my first term. And then I'm repeating a minus 2, and I used my first term. So that's how we can just set up in general. If I want to do my distributive property, d of t equals 34 minus 2n. Negative 2 times a negative 1 is plus 2. So then simplified, 34 plus 2 is 36 minus 2n. So this is the equation you can substitute these different numbers into. So you can fill in the boxes from there, but that gets you started. All right, let's look at the next page. Elvira, we're back to Elvira. She has been running a private catering business to make extra money. She needs some help organizing the information in problems 7 through 10 below so she can better predict amounts to purchase and improve profits. Assist her by organizing the information in a meaningful way, aka matrix, so that she can average the years and do better the coming year. So the last 3 years, she's catered family gatherings and city events. Last year, she provided the following at a family gathering: 5 bags of chips, 6 dozen cookies, 4 gallons of drink. Last year at a city event, she provided the following: 16 bags of chips, 20 gallons of drink, and 24 dozen cookies. So let's set this up in a matrix. So just like we did the other day, we had chips, chips, let's not do any capitals, cookies, and drinks. And so then we had a family gathering and we had a city gathering, right? So let's go with the family one. So the family one, if we go back and look, had 5 bags of chips and 6 dozen cookies and 4 gallons of drinks, 4 gallons of drinks. The city one, which makes sense, it would be bigger. She had 16 bags of chips, 20 gallons of drink, and then 24. Oh, dozen cookies. Oh my goodness. They mixed them up on us. 24 cookies. Don't trust them to put it in the correct order, right? So chips, drink, cookies. So cookies is 24, drink is 20. All right. So here is our matrix of her organization. Okay, 2 years ago, Elvira provided the following at family events. So let's see. At a family event, at 5 gallons of drink, 4 bags of chips, and 5 dozen cookies. And the city had 20 dozen cookies, 18 gallons of drink, and 12 bags of chips. All right, so let's organize this one. Same thing, but do this one a different color. All right, so get some space up here. We have chips, cookies, and drink. I'm going to keep these all in the same order so that they're consistent throughout. Family and city. All right, so family, how many chips? 4 bags of chips. I'm going to look for labels this time. She didn't do them in the same order. And 5 dozen cookies. And then 5 gallons of drink. Okay, so then the city one, how many chips did she provide? 12 bags of chips. And the cookies were 20 dozen cookies. And then 18 gallons of drink. All right. And 3 years ago, she provided the following at city events. So we're doing the city first: 14 bags of chips, 20 gallons of drink, 19 dozen cookies. And the family gathering had 6 bags of chips, 7 dozen cookies, and 9 gallons of drink. So let's go back to our text box and let's do this guy. So this year's, or 3 years ago. All right, so again, I'm going to do chips, cookies, drinks. Even though she's mixing up the order, I'm going to keep my labels the same. Family on first and city down below. Let's get that over just a tad. Okay, so family had 6 bags of chips and 7 dozen cookies and 9 gallons of drink. And then the city one had 14 bags of chips and that's 19 dozen cookies and 20 gallons of drink. Okay, so we're just setting this up in a little more organized fashion. All right, number 10. If you provide Elvira with an average amount to be ordered for the gatherings and the events she caters in the coming year, how much of each item would she need? Present the average in an organized way. So first I'm just going to list what they had. So I'm going to see if I can fit it all on my screen. So we're going to start with family. And the chips were 5 plus 4 plus 6. 4 plus 6, and that is 15. And there's 3 things, so divided by 3 equals 5. So I'm going to want to use 5 in my matrices for that piece. So I'm going to go ahead and let's start that over here. A little more space. Chips, cookies, drink, family, city. Okay, so I've just figured out that the family average for chips is 5. Okay, I keep going over here. So when I do cookies, I need to use 6 plus 5 plus 7. 6 plus 5 plus 7 equals, so 11 plus 7 is 18. Divide by 3 for my average, that one's 6. So the cookies needs to be 6. And let's do drinks. All right, so the drinks were 4, 5, and 9. So 4 plus 5 plus 9, that's not a 4. So 9 plus 9 equals 18. Oh, running into my screen there. Divided by 3 equals another 6. So now I've just figured out my averages for the drinks. Scoot this over so I can do the city one. All right, so city chips, we had 16 plus 12 plus 14. 16 plus 12 plus 14. And that equals, let's see, we have 16 plus 12 plus 14 is 42 divided by 3 equals 14. So the city's chips average is 14. Okay, back over here. Now we need to do cookies. And so the 3 sets of cookies were 24, 20, and 19. So 24 plus 20 plus 19. And that equals 63 divided by 3 would be 21. Oh, we put the 21 over here. And then I need to do the last one of drinks. All right, so they had 20, 18, 20. 20 plus 18 plus 20. And so that equals 58. 58 divided by 3 equals, so that's actually 19.3 repeating. So we're going to go ahead and just put that in here as our number. I mean, she'll have to decide if she wants to round up to 20 or round down to 19 when she gets to that point. But there we've got everything labeled for her. So it was a good thing that we set this up all in the same order so that it was easy to add an average for our final one. All right, last page. Remember the sequences from the beginning of the year. For each sequence below, determine whether it's either arithmetic or geometric and find both recursive and explicit. So no, these are not going to go away. You still need to be figuring out how to do these and continuing them. So we are doing looks like a plus 2, plus 2. So that would be arithmetic. So my f of 1 equals 1. And f of x equals f of x minus 1. And what am I doing each time? Adding 2. So my explicit is I started with 1, f of x equals 1 plus, because I'm adding 2, but my first term is a 1, so n minus 1. All right, so this one seems to be a times 2. So that's geometric. Okay, recursive is f of 1. Oh, f of 1. I'm going to start with my first term. F of, it's not drawing, 1 equals 3. F of x equals f of x minus 1. So the previous term times 2. So my explicit then is my starting term times 2 repeatedly, but I need to take away that first term. So I started with the first one. All right, 13. This should all be, but we're still going to do it because I want to make sure we got this down. So what is happening is we're going to each one. Looks like a plus 4. So that is arithmetic. Recursive is, got my first term up here. So f of 1 equals 3. F of x equals my previous term, f of x minus 1. And what am I doing over and over? Adding 4. So explicit then, I started with 3. I'm going to add 4 over and over. I need to take out that first term. This one, Not as straightforward, but I can see it's not a plus 3 each time. So I'm going to take 8 divided by 5 and just see what I get. I get a 1.6 times 1.6. I take 12.8 divided by 8. I also get a 1.6. So times 1.6. So I took 8 divided by 5 to get 1.6. I don't know why that's not drawing very well. That is geometric. So our recursive is f of 1 equals 5. So f of x equals my previous term, f of x minus 1, times 1.6. Explicit, f of x equals my first term of 5 times 1.6 over and over, but I need to take the x minus 1, so that's the exponent. All right, last two. Now, Valerie likes to exercise in her spare time. She has been running. The first day she went running, she did 100 yards, and she's been running an additional 50 yards each day she works out. So if she's adding 50 yards, that would be arithmetic. F of 1, she said her first day she did 1,000 yards. So f of x equals f of x minus 1. What does she do each time? Plus 50. So my explicit f of x equals my first term, 1,000, plus 50 repeatedly, but I need to get rid of that first term. All right, big finale. Evan has started a business and following Bill's example is going to send out a chain email to get customers. He sends the email to 5 people on the first day, and they're each going to send it to 7 people. Then those will send it to 7 more, and so on. Looks like a times 7 on here, doesn't it? Geometric. So f of 1, first day, he sends it to 5 people, but then f of x is going to equal, then everyone after that is going to times 7. So explicit is my first term of 5. I'm going to times 7 over and over, but I've got to take out my, since I'm using my first term. All right, thanks for joining us, and we'll see you next time.